Okay, the topic of today's meeting, I would like to show you some of Builder tool, which is called CLC Dependency Tree, and then we will have a look on some scripting, data exchange structure, and some tips for better scripting, especially some boolean switchers and integer switchers, how to handle them and use in the script. So the first of the topic, CLC Dependency Tree. As you can see on my screen, I have opened some calculation, which is design of longitudinal reinforcement for a rectangle. And in the right window, I have the CLC Dependency Tree. It shows me all external CLC files which are used in this master. These are in the first level. So for example, let's have a look on this one, design reinforcement for rectangle. We can see that it calls two another calculations, which each of them use calculation in third level, some clause. You can use this CLC tree view to have an insight what's the content of the CLC, what are the dependencies, but you can also use it for fast navigation in the script. As you can see, we have these numbers with blue font and underline, which are used as a shortcut or let's say hyperlink to the line which calls this calculation. So when I click on this 41, script scrolls to the command which load this external CLC file. And clicking moves me to line 60 and so on. In the last column you can see three dot button, let's say, which is used to open that calculation, of course, only if you have source code CLS file available. I do have, so when I click on the three dot button, the calculation opens in a new tab and I can edit it, re-export and use in the previous calculation from which I called it. So that's used for fast navigation and fast access to external CLC files. This column shows me the license ID which is used for the specific calculation. So I can see that most of them is protected with license 10,000, which is public license. Close calculations are protected with 706, which is so-called free license. This license code is readable for anybody. Anybody can open this calculation and use it. That's the let's say unprotected, some kind of support for external developers to use NADs of Eurocode. So there's this column. The first column, the ones, tells me how many times the CLC is used. I see that all of these are one. I have to switch to compact mode to change it. In this calculation, all external CLCs are called just once, but I can make, for example, this one, refresh and update once again, and you can see now here is the number 3. So this external calculation is used 3 times. That's the difference between compact mode and full mode. In full mode I see each instance of concrete material and I can use this navigation to the lines of code. In compact mode I see only one row, but I see that there are 3 instances of this. The line code is of course unavailable because there is no line which I can skip to. So this is the CLC dependency tree. Is there any question for it or some maybe experience, request for improvements or something like that? I will check the chat.
I have actually a question regarding those license numbers. You mentioned 10,000 is public license and 706 is free license. What's the difference actually?
706 can be used by anybody, even without license. Or imagine a user who has license, for example, 10,020, which is, I think, SCIA concrete section. So he has the only module 10,020. He is able to read this 706, but he is not able to read 10,000. You have to have 10,000 module in your license to be able to read it. Yeah? It's called public license because if you buy Designforms Builder as an end user, you can create only calculations protected by this 10,000 module, nothing else. You have to register at SCIA and buy some developer key to be able to produce so-called commercial modules, commercial CLCs with your own license ID. Yeah. Did I explain it? Do you understand?
Okay.
Yeah. Okay. 706 in fact is unprotected. Yeah, it's readable for anybody, even without any license. Any other question? If not, we will move to the next topic, which is data exchange structure. Data exchange is something which is used for communication between master and external CLC. First, I will show you direct access from master to external CLC calculation and try to describe some problems which may appear in this. We have some external calculation which calculates volume of a brick and the weight. So, sorry, moment. Okay, so that's a simple calculation. With direct access, I can use, let's say, old technique which sets properties of the external calculation directly. You can see it here. It works, and I have no problem with that. You can see that the calculation is okay, and the weight is also calculated properly. But issues which we faced in the past, typically external calculation can be extended or refactored, or is there some change, which leads to a situation that you don't set all properties of the external calculation which are necessary for proper calculation. In this example, I omit property B and C. So you can see that the calculation is still okay. It still calculates, but it uses values from the previous run. So I have no control about property B and C, and I'm not notified that I didn't set it, which obviously can lead to mistakes, errors, and really difficulties to find the issue, the source of the problem. Another kind of problems which may appear in this situation is that you, or the user or developer of the master CLC, uses incorrect argument, incorrect value of the property. In this case, I use a negative number, which is obviously nonsense for a real pad or a brick dimension. No brick can has a dimension -5. The calculation proceeds, everything's okay, but obviously it's physical nonsense to have -60 volume. Again, we are not notified that something is wrong, that the parameter is outside of proper values. Again, very difficult to find the problem. So the solution for these issues were something which we call data exchange structure. How it works? I have published some example on the Design Forms forum. I will try to find it. I'm not prepared now, sorry. That's my mistake. Data exchange. So here you can see the schema, how it works. When you want to use data exchange, you have to call proper variant of calculate or draw command. I will show you which is it. It's the with parameters input and output. If you use this variant of command, Design Forms automatically call a function which is called validate input, which is defined in external CLC file. That's it. This will be called automatically. If everything's okay, it means that no exception was thrown and the function returns true, that it accepts the input. Then the external calculation is executed. After it finishes, function get output, again defined in the external calculation, is called, which produce the return value of the calculation. This return value is then provided back to the master CLC file. We have two options or two possibilities where this call can fail. The first, when exception is thrown in the validate input function, it means that something is missing in the input structure or something went wrong. The second option is that the validate input returns false. It means that the input is not acceptable. For example, we have provided a negative value for the dimension, as I showed in the previous example. Yeah? Then the function returns false. Calculation external CLC is not calculated at all, not drawn, not calculated, and returns a null. And the null value is provided back to master CLC. So let's have a look how it works in real practice. I have external calculation. This is it. It's the same calculation as we used in the previous example. So we calculate simply the volume and the weight of some pet. And we have function validate input, which reads the data from the input structure and check if the value is correct, is in fact a positive value. Yeah? If not, we throw some exception and return false. I will show you how it looks when the exception is thrown or the false is returned. So back to the master CLC, I create the input structure which defines obligatory properties. These are A, B, and C. I link them with the local variables, but there is in fact no relation between name of the local variable and the name of the property of the input structure. Yeah, you can see that the property is A, and I assign the value of the width variable. I create this, then I can or I don't have to set also the rho, which is the density of the material, and call the external calculation. In this example, I will show you first when everything's okay. So let's have a look. All the values are positive. Input structure is properly defined. So everything's okay. Input, validate input returns true. So the external calculation is drawn and returns the value in the variable output, which is then read and returns volume 18.8 and some weight of the pad. Yeah. So everything's okay in this case. So let's have a look what happens if we provide wrong parameters, wrong input data. I showed that before. So I've inputted negative height of the pad, and the external CLC says no, I can't use this input, and tells me what is wrong. Let's have a look in the external CLC how this is how it's made. I read the width, height, and the depth from the input structure. There is no check at all. It simply reads the values. Here I check if it's positive. If not, I throw an exception using EVN, which is error warning node system. As you can see, the first letter is E. It means that it's error, and the error is defined in EVN file. We will have a look at EVN on the next training. So now simply believe that it do what it has to do, and we return false. Throwing this runtime error is not necessary. It just helps me, or the user of external CLC helps him to understand what is wrong. But it's completely enough to return false. Yeah. I can return false directly at this place. I can do this, which immediately stops execution of this method and returns false, and we are done. The reason why I assign the local variable result and go through all the code is that I provide all errors for a user at once. Yeah. It means that if I will put it back, if user provide me several wrong inputs, I will get all of them. Yeah. As you can see, he tells me that the width must be greater than 0, height and depth. If I would stop here with return false, I wouldn't get to these commands, to these instructions, and I would have to check and operate correct this input to get to this line, and he tells me again there is another error, check it, and so on and so on. So this is better solution to make sure that we will check all parameters. Yeah. So let's put back proper values, and let's have a look what happens if we omit some parameter. Let's say that we will not provide the B parameter. When I refresh, he tells me that something is wrong. Input does not contain property B. So this is handled automatically. When this value is read from the input, it throws an exception. Directly, I don't have to take care about this. It's made automatically by design forms. Exception is thrown. The execution is stopped immediately at this line, and I get this runtime error in the master CLC. As you can see, the input structure contains only properties A, B, and C, but we are reading also the density, the row. So why does it not throw an exception on a row? The difference is this second parameter. It's called the default value, and it tells me, or the master CLC, that this parameter is optional. User can, but he don't have to set this parameter. It can be used typically when you extend your calculation and use new input parameter which was not used in the previous versions. So you will make it optional, with some default value, which makes it available also for older masters, which calls this your external calculation with old parameters. Yeah? So that's why we made also optional parameters with default value. So this is the difference. If the value is set, then we use the value from the input. If it's not set, we use 2060. The output of the extern is defined by this getOutput function, which is called automatically when the main script finishes. You can return anything you want. I suggest to return a structured variable which can be easily extended, but theoretically you can return, for example, string, number, or boolean. It's not a problem. Yeah? It's up to you, but again, strongly recommended to return a structured variable which can be extended in the future if you want to extend the number of results which comes from this calculation. Reading in the master is very simple. We test if the output is or not null. It means if the call succeeded. If succeeded, we type everything's okay and print the output. If not, I draw a table of EVN. We will discuss it on the next training. Yeah. This example is saved on Design Forms forum, so you can download it and play with that, test what happens in each case, and test it. Yeah. Is there any question? I see something is in chat. Yeah, sorry, it's to the license. So some question to the exchange structure. Everything's clear. It's almost unbelievable. Okay, so let's proceed to the last topic of today's meeting, and that's tips for better scripting. I will show you example of some older script which uses not optimal solution for boolean switcher. As you can see, there is some condition which tests normal force if it is greater or not to some limit value. Here the author used two numerical values, numerical variables set to 0 or 1. In else branch, he uses the same variables with opposite values. I think this is not a good solution because this condition is simply true or false, but two numerical variables provide infinite powered on two possible values which can contain these variables. Yeah? In my opinion, better solution of this, sorry, I'll open it. Better solution for this can be something like that we make, where is it? We create some boolean variable and assign directly the value of the expression absolute of normal force is or not greater than some limit value. I pretty often see something like that there is an if statement which contains this is compression equals to true and is compression equals to false. Obviously, these two expressions are exactly the same, but I believe you agree that this expression is much shorter and at least for me, better understandable what is going on and what happens. So there's a suggestion, if you need to distinguish two options, two lines of code or two paths of code, use something like that. Assign the result of the expression to Boolean variable and then use directly the variable in the script as a Boolean variable. Yeah. Another thing which I would like to show you is using a switch statement based on the integer value. So let's say we have some numeric variable, for example index or type, better will be type, and we have three possibilities, three options which can be handled. Yeah? The type can be 1, 0, 1 or 2. But pretty often happens that calculation is extended, something is changed, and for some reason we get that the type is, for example, 3. And what happens? If the type is 3, this switch case statement is not executed at all because we have no case 3. So this instruction in fact is ignored and nothing happens. You are not notified that type was 3, was outside defined case statements, and it's again a source of errors, problems, and it's difficult to find a source of this problem. So I strongly recommend to use default statement, which for example tells me unsupported type. Yeah. This is enough. This tells you, hey, something is wrong. I don't think that type can be anything else than 0, 1 or 2. Yeah. At least you will be notified that something happens, and you should have a look why you get other type other than 0, 1 or 2. Yeah. So these are two recommendations: to use Boolean variables if it's really true or false. Don't use numeric variables for this. 0, 1 is not okay because numeric, even integer variable tells you there is more than 2 possibilities. Yeah? If it's Boolean, it tells you it's very simple, it's true or false, nothing else. There is no other option. Yeah? Numeric gives you infinite number of options which can happen. So these are my recommendations for Boolean and integer switches. Is there any question to this or some note? I think you use it pretty often. I see it in almost all samples which gets to me. So please consider these and avoid possible issues and problems with these switchers. So if there is no question, I thank you for your attention. I wish, I think everybody has a long weekend. The 1st May is holiday, so enjoy the weekend and have a nice rest of the day.
Thanks, Peter.
Yeah. Bye-bye.
Thanks, bye. Thank you, Peter. Bye.